In this example video, I am going to show you how the precipitation kinetics calculation can be performed in MatCalc. This calculation provides you with the information about the evolution of the precipitate state in the system at various conditions which will usually determine the properties of your material. Create new workspace by clicking on New in the File menu. Select MatCalc Workspace on the drop-down list and click on OK button. Click on the Global menu and then on Databases to select the elements and phases present in this simulation. In this example, we will simulate a nickel alloy, so select MCNI database and open it. In the elements list, select aluminum, cobalt, chromium, molybdenum, titanium and tungsten. In the phases list, select the phases FCCA1 and gamma prime. Afterwards, click on Read. Next, select the diffusion database by clicking on Diffusion Data on the left side of the window. Then, click on Read. Select MCNI DDB file and open it. This will load the parameters describing the diffusion in this system. Click on Close to finish this part of the setup. Now, the composition of the system will be set. Click on the Global menu and then on Composition to set the alloy composition. In the Nominal Composition window, select Weight % on the bottom and set the following element contents: 2 for aluminum, 14 for cobalt, 16 for chromium, 3 for molybdenum, 5 for titanium, and 1 for tungsten. When done, click on OK button. Initialize the system numeric by clicking on Set Start Values in Calc menu. Afterwards, perform a stepped equilibrium calculation. In order to do so, click on Stepped Calculation in Calc menu. The default settings will perform a calculation in the range between 400 degrees Celsius and 1550 degrees Celsius with a step of 25 degrees Celsius. Click on Go button to perform the calculation. Let us plot the phase fraction as a function of temperature. In View menu, click on Create New Window and change the view to the User Defined tab. Select the second record, which defines the phase fractions expressed on a linear scale over the temperature, and click on OK button. On the plot that appears, we can see that the gamma prime phase is stable below 1150 degrees Celsius and reaches the phase fraction of about 45% at 400 degrees Celsius. Now close the window. In order to start the precipitation kinetics simulations, 3 things need to be defined. The first one is the precipitation domain, which is the phase in which the precipitates are going to appear. The second one is the precipitate phases themselves. The last thing that needs to be defined is the temperature time program, which will describe the processing of the material. To define the precipitation domain, click on Global menu and then on Precipitation Domains. In the new window that appears, click on New on the bottom left side. In the new Precipitation Domain window, specify the name of the domain. In this example, I will call it Matrix, but you are free to name it as you wish. Click on OK to confirm. In the Thermodynamic Matrix Phase section on the top right side of the window, a drop list is available, where the phase which will constitute the domain can be selected. Leave the FCCA1 phase selected and close the window by clicking on the OK button. In the next step, the precipitate phase will be defined. In Global menu, click on Phase Status and select the gamma prime phase on the list in the window that appears. Next, click on Create on the bottom left side of this window. In the Create New Phase window, select Precipitate in the drop list, and click on OK. A new phase gamma prime P0 appears on the list. Click on OK to close the window. It is now time to define the temperature time program. In Global menu, click on Thermomechanical Treatments. In the appearing window, click on New and give a name to the heat treatment we are going to define. I will name it Test Treatment. Click OK when done. Next, click on the New Segment button. As you notice, the lists in available treatment and data sections were modified by these operations. Select the first row with the numbers in the data list and double-click on it. In this window, the very first process operation will be defined. First, set the value 1200 in the start temperature field. Next, define the end conditions of this segment. In the ramp control section, leave the end temperature and heat cooling rate in the drop list and type in 900 in end temperature and 0.02 in cooling rate fields. The minus sign indicating the cooling can be neglected. Now, define the subsequent segment. Click on the plus button to proceed to the next segment. Confirm the creation of the new segment by clicking on Yes. Here, we change the end condition parameters by selecting heat cooling rate and delta time from the drop list. Type in minus 0.01 in cooling rate and 8 times 60 times 60, which stands for 8 hours expressed in seconds, in delta time fields. To define the data for the last segment, click once again on the plus button. Confirm the creation of the new segment and set in temperature and delta time in the drop list. Type in 400 in end temperature and 11 times 60 times 60. This stands for 11 hours, in delta time fields. Click on OK to exit the segment definition window. In the preview section of the Edit Thermomechanical Treatments window, the temperature time profile of the treatment is depicted, and the parameters are summarized in the table displayed in the Data section. Click on OK button to continue. With all these settings done, a precipitation kinetics simulation can be performed. In Calc menu, click on Precipitation Kinetics. In the new window, switch to From Heat Treatment in the Temperature Control section and select the name of the defined treatment on the drop list. Then, simply proceed with clicking on Go and confirm with clicking on Yes button. The calculation results will appear in the MatCalc console window. It contains a lot of information about the precipitation domain and phases at various time instances, like the compositions, driving forces or dislocation densities. Another way to visualize the results of the precipitation kinetics simulation is to plot some characteristic parameters. In View menu, click on Create New Window and switch to User Defined tab. Select the fourth item on the list, Kinetics, 4 frames, T, F, N, R, Linux and click on OK button. This will create a new window with 4 plots. On the top left plot, the temperature, time progress is shown. On the top right plot, the phase fraction of the gamma prime precipitates is shown, indicating that the precipitation process occurs in 2 steps, reaching the phase fraction of about 30% in the first step and increasing further to over 35% in the next one. On the left bottom plot, the evolution of the precipitation number density is shown, indicating that actually there are 3 precipitate nucleation waves occurring as 3 steps can be distinguished on the curve. The latter observation is supported by the plot on the right bottom side. Here, the mean radius of the precipitates is displayed, which stepwise decreases, as every new precipitation wave results in the formation of the small-sized nuclei which affect the mean value. You can learn more about how to work with MatCalc by viewing other example videos. Thanks for watching.